Hey guys, in this video we're going to have a look at some must-know things to do with electron subshells. In later videos in this series you will be looking at electron subshell configurations, and in order to properly represent those and properly unpack those, you need to know all the things that will be discussed in this video. Okay, so the key learning goals as usual are identified just over here, and you need to be able to name the 4 types of subshells. So we're going to start with that. Now the 4 types of subshells, there are only 4 types, are the S subshells, the P subshells, the D, and the F. Those are the 4 types of subshells, okay? Now there's a mnemonic for remembering these. I'm sure there are many more better ones out there, but for the one that I use to remember them, if for some reason I've forgotten, is that sober physicists don't fart. Sober physicists don't fart. SPDF. All right, maybe you can come up with a better mnemonic, but the main idea is that it helps us, or at least helps me when I forget, to remember the order of those subshells. Okay, so we've identified those 4 types of subshells. Now we need to be able to identify the number of orbitals and hence electrons in each subshell. Okay, so maybe before we go to talk about how many orbitals are in each subshell, let's just look at what the word orbital even means. So when we talk about electron orbitals are the regions in the atom that can hold up to 2 electrons. So if we imagine an atom is a 3-dimensional entity, an orbital could be some area that you would find electrons floating around. So electron here might be flying that direction, electron there might fly that direction, and the orbital is like the region that the electrons are typically bound within, so they'll only be flying around that region. But the basic definition is that these are electron regions that can hold 2 electrons. Okay, so the S subshell has 1 orbital. And if you know that 1 orbital holds 2 electrons, then the S subshell can only hold 2 electrons at maximum. Now a P subshell has 3 orbitals. So what's the maximum number of electrons a p orbital can hold? That will be 6 electrons. Notice how there's a difference of 2 between the S subshell. There's a difference of 2 in the number of orbitals of the S subshell and the P subshell. You can see here there's a difference of 2 between S and P, and you see that difference again between P and D, because D has 5 orbitals and hence can hold a total of 10 electrons, and the F subshell has 7 orbitals, again a difference of 2 from D, and so it can hold 14 electrons. Now you need to know the number of electrons that each of these subshells can hold. So you can see the difference of 2 between each of the orbitals. You can, as a result, see a difference of 4 electrons between each consequent orbital subshell. So the S subshell is 2, you add 4 to go to the P subshell to have 6, you add 4 when you go to the D subshell to get to 10, and then 4 more to get the F. So Here are just some memory aids to help you remember the number of electrons if you ever happen to forget. All right, now the last thing that we're going to do is unpack a written representation of a subshell. A written representation of subshell, what I call the building blocks of the Electron subshell configuration, which we will look at in later videos. So what is a written representation of a subshell? In other words, if we had to represent in writing an Electron subshell, what would it look like? Now, a typical example would be, let's say, 2s1. Okay, so you can identify perhaps 3 components in this this written representation. You can identify 1, 2, and 3. So let's just go through each of these 3 components. This first number here, this big coefficient, if you like, to the left of this written representation of a subshell, represents the shell number. Some people say this is also known as the energy level of that subshell. So this number 2 tells us that this particular subshell that we're looking at, this subshell here, what we're looking at is a subshell in the second shell of the atom. So remember, the atom's electrons are arranged into shells, and subshells are just pieces of those shells. So the subshell meaning less than the shell, and it makes up the shell. So the second shell is made up of actually 2 different subshells. There's this 2s subshell, but there's also a 2p subshell. And so, so this first number tells us the shell number. So what shell you would find this subshell in, or what energy level you would find this subshell in. The S is the type of subshell. We've just looked at the 4 different types of subshells, so that's easy. And this little superscripted number here, so superscripted number, so superscript meaning a number that is like in a smaller font and is like at the top right of the previous normal character. So it's at the top right of S, and that's superscripted to S. Superscripted number 1 tells us, or the superscripted number tells us the number of electrons in that subshell. So if we look at the 2s bit, which tells us that this is an S subshell in the second shell, so this is an S subshell of the second shell, the 1 tells us that there's 1 electron in that S subshell of the second shell. So if you had to fully write out in words 2s1, what that really meant, like just in a sentence, you would say this subshell is the S subshell in the second shell and it contains 1 electron. Okay, and there we have it. This is how we unpack a visual representation of a subshell. Now I'm just going to throw some examples at you, just to give you some practice. So we've got here 4p5, unpack what that means. 5d1, 3s2. Okay, so unpack what these mean, or what these mean. I'm just going to I'm going to ask you to pause the video and have a go at these, and then I'm just going to write what they are out. Okay. All right, so I've written for these 3 different building blocks of the Electron subshell configuration the following. So for the first one, I've written for 4p5, the p subshell of the fourth shell that has 5 electrons. And for 5d1, the d subshell of the fifth shell has 1 electron. And for 3s2, the s subshell of the third shell has 2 electrons. Okay. All right, guys, thanks for watching.